Hi dear students of plus 2, medical, non-medical and respected teachers. Today I am going to discuss model of atom. First I will discuss Thomson model of atom, then its limitations, then Rutherford model of atom and its limitations. So first of all, what is Thomson model of atom? According to Thomson model of atom, each atom consists of a positively charged sphere of radius of the order of about 10 raised to minus 10 meter, which is responsible for almost entire mass of the atom. And the electrons are embedded just like plums in pudding or seeds in watermelon. जैसे watermelon ਨੂੰ ਕੱਟ ਕਰੀਏ ਨਾ ਤੇ ਉਹਦੇ ਜਿਹੜੇ ਸੀਡਸ ਨੇ ਜਿਸ ਤਰ੍ਹਾਂ ਦਿਖਾਈ ਦਿੰਦੇ ਨੇ ਸਾਨੂੰ ਉਸ ਤਰ੍ਹਾਂ ਇਲੈਕਟ੍ਰੋਨਸ ਪਏ ਨੇ ਸਫੀਅਰ ਦੇ ਅੰਦਰ. The sphere positively charged, uniformly distributed है. Electrons are embedded just like plums in pudding or seeds in watermelon. That's why it is also known as plum pudding model we can use. So this is Thomson model of atom. But it was discarded due to some limitations. Number one, if electrons are embedded just like plums in pudding, how number of atoms, H atom and other atoms show spectral lines from where they origin. So if electrons are fixed, so how spectral lines are formed? So it means it could not explain the origin of spectral lines in so many atoms, in hydrogen atom and other atoms. Second, it could not explain Rutherford's scattering of alpha particles from a thin gold foil. If it is a positively charged sphere, how alpha particles get deflected, how alpha particles pass through the gold foil. So these were two limitations of Thomson model of atom. That's why then Rutherford performed an experiment known as Rutherford's alpha ray scattering. What he took a source of alpha particles in a lead chamber S. Then he used a collimator to get fine beam of alpha particles. Then there is a thin gold foil, very thin gold foil of the order of 10 raised to minus 8 meter thickness. Then there is a screen, and where screen using zinc sulfide fluorescent screen, where a microscope is used to detect alpha particles, to count number of alpha particles scattered through the gold foil at different angles. Then what he saw, Rutherford saw that most of alpha particles pass through the thin gold foil, almost undeviated. So बहुत सारे alpha particles almost undeviated pass करके thin gold foil ਦੇ ਵਿੱਚੋਂ, which were detected with the help of detecting microscope, and very few get deflected at small angles, that is get scattered at small angles theta, about 8-10 degree, and a very few got deflected at large scattering angles, more than 90 degree. So then from this experiment he made some observations. No, most of alpha particles pass undeviated. What it means? It means there is a lot of empty space within the atom, because alpha particle is a positively charged particle having charge plus 2e. So it passes through the thin gold foil. It means there is a lot of empty space within the atom, pass undeviated. So, and he counted the number of alpha particles scattered. Then he plotted a graph between taking angle of scattering along x-axis and the number of particles scattered or counted along y-axis. Then he got a graph like this. And the number of particles scattered is inversely proportional to 1 upon sine power 4 theta by 2, or n theta is directly proportional to cosecant power 4 theta by 2. Theta is the angle of scattering. Direction of scattered alpha particle makes with the initial direction is called the angle of scattering, which is theta. So from this graph we can see that as angle increases, number of particles scattered decreases. So very few, about one particle in thousands, 8,000, 10,000 particles get deflected at an angle more than 9 degree. So from these observations, then Rutherford proposed a model of atom known as Rutherford model of atom, which states that number one, according to Rutherford model of atom, number one, there is a lot of empty space within the atom. It means the positive charge is situated at the central core of the atom. Positive charge is situated at central core of the atom, which is responsible for almost entire mass of the atom, and that central core, positively charged central core, is known as nucleus of the atom. So which is situated at the center and contains the whole positive charge and responsible for almost entire mass of the atom. So it means Rutherford discovered nucleus of the atom. This experiment was to discover nucleus of atom, but because in case of Thomson model atom, there was nothing about nucleus of the atom. Third point, what about electrons? He said electrons are revolving around the nucleus because there is a lot of empty space. Electrons are revolving around the nucleus in circular orbits, and the necessary centripetal force required for this purpose is provided by the electrostatic force between the nucleus and the electron, because for circular motion centripetal force is needed. Fourth point, atom is electrically neutral. That is, total negative charge equal to total positive charge. So atom is electrically neutral. It was also said by Thomson, atom is electrically neutral. Whole negative charge equal to whole positive charge. But he said electrons are embedded in, just like plums in pudding, electrons are fixed. But Rutherford said electrons are revolving around the nucleus in circular orbits, and necessary centripetal force is provided by the electrostatic force between the nucleus and the electron. Size of the nucleus, he said, he calculated the size of nucleus is of the order of 1 Fermi, 10 raised to minus 15 meter, which is less than the size of atom. He proposed the size of atom as 10 raised to minus 10 meter. So nucleus is supposed to be situated at the center of the atom, so its size should be very small as compared to size of atom, because there is a lot of empty space. So to calculate the size of atom, he did some experiment again and discussed the theory of this experiment, alpha Rutherford scattering experiment. What happens? Suppose an alpha particle, which is He24 helium nucleus having charge plus 2e, when it is bombarded on thin gold foil, suppose it approaches the nucleus of atomic number Z having total charge plus Ze. So when alpha particle approaches the nucleus, alpha particle with some kinetic energy, with some velocity. So kinetic energy E, suppose kinetic energy of alpha particle is equal to half mv square. So when an alpha particle having some kinetic energy approaches the nucleus at rest, then what happens? Its kinetic energy kinetic energy of alpha particle goes on decreasing as it approaches the nucleus because of electrostatic force of repulsion between two like charges. And as soon as it approaches a particular distance r naught from the nucleus, kinetic energy becomes zero. And this distance at which kinetic energy of alpha particle becomes zero from center, this distance from center of nucleus is known as distance of closest approach. So particle cannot go further or cannot enter this boundary of the nucleus, which is r naught, distance of closest approach. After then, because of repulsion, its kinetic energy becomes zero, it rebounces back in the opposite direction. So at the distance of closest approach, it means kinetic energy of alpha particle becomes equal to the electrostatic potential energy of the nucleus and the alpha particle. So if alpha particle kinetic energy is half mv square, electrostatic potential energy, by definition of electrostatic potential energy between two charges, is 1 upon 4 pi epsilon naught q1 q2. q1 is Ze, q2 is 2e over r, distance anywhere from the center of nucleus. At r is equal to r naught, the distance of closest approach, this electrostatic potential energy becomes equal to kinetic energy of the alpha particle. Therefore, half mv square is equal to 1 upon 4 pi epsilon naught 2 Ze square upon r naught. From this we can find r naught is equal to 2 Ze square upon 4 pi epsilon naught half mv square. That is, knowing kinetic energy of alpha particle, approaching alpha particle, which is known. Atomic number, charge upon nucleus electron is also known. 1 upon 4 pi epsilon naught is also known. So we can calculate value of r naught. Distance of closest approach, which comes out to be 10 raised to minus 15 meter, which is of the order of 1 Fermi. It means nucleus will have radius less than this 10 raised to minus 15 meter, because nucleus cannot enter, alpha particle cannot enter the boundary of the nucleus because of repulsion. So size of nucleus is taken to be, maximum size of nucleus is taken to be 10 raised to minus 15 meter. Then we define, we can see that r naught more the energy of alpha particle. So r naught may vary with the kinetic energy of the alpha particle, but alpha particle will definitely stop at certain distance, at distance of closest approach. Then impact parameter. Just definition you have to remember. Derivation of this expression for impact parameter is not in your syllabus for +2. So impact parameter means suppose this is the center line of action, center of line passing through the nucleus of the atom. So when alpha particle moves along the center line, so impact parameter will be 0. But when it is at a certain distance, so then distance of initial direction of motion of the direction of velocity, the direction of velocity of the alpha particle from the center line when alpha particle is far away from the nucleus is called impact parameter. So this means perpendicular distance between center line and direction of velocity of alpha particle when alpha particle is far away from the nucleus is known as impact parameter. When it approaches, it gets reflected at some angle theta. Theta is angle of scattering, and this impact parameter is given by 1 upon 4 pi epsilon naught Ze square cot theta by 2 over E. It means impact parameter is inversely proportional to kinetic energy of alpha particle. So more the kinetic energy of alpha particle, less is the impact parameter. So and then some limitations of Rutherford model of atom. So basically there are two limitations. According to Rutherford model of atom, electrons are revolving around the nucleus in circular orbits, and necessary centripetal force is provided by the electrostatic force between the nucleus and the electron. It means there is centripetal force, it means there is centripetal acceleration, it means electrons are being accelerated. And according to classical theory of electromagnetic theory, any accelerated charged particle loses energy. It means if electron evolving in the circular path, with the passage of time it loses energy. It means its velocity decreases, its radius of circle decreases, and this continues, and ultimately this electron may fall into the nucleus. So this spiral radius goes on decreasing. It means atom is unstable, but most of the atoms are found to be stable. It means every atom is unstable if electrons are revolving in circular orbits, and due to classical electromagnetic theory, any accelerated charged particle will be losing energy continuously, and its radius goes on decreasing. Ultimately, it will fall into the nucleus and atom becomes unstable. So it means Rutherford model of atom could not explain the stability of the atom. Number two, since it is radiating energy continuously, electron, and there is no specific circular motion, it means it should emit loss of energy. Energy radiated in the form of electromagnetic radiations should be of continuous nature. The spectrum should be continuous, but we get line spectrum of hydrogen atom and some spectral lines in other atoms also. So it means it could not explain the line spectrum of H atom. Spectral lines produced by electromagnetic waves or various atoms. So these are the two limitations of Rutherford model of atom. Number one, it could not explain the stability of the atom, and number two, it could not explain the line spectrum of hydrogen atom and some other atoms. So this is all about Rutherford and Thomson model of atom. In the next video, I will discuss Bohr's model of atom. Till then, stay tuned, be happy, good luck, all the best. Sarbat Dapala.